Before we begin in Access, I think it's important to outline a few key concepts about what a database is and define some of the keywords we'll be hearing throughout the course. So what is an Access database? An Access database is not just a place to store your data, it's a tool for creating a custom application that wraps the entire interaction between you, your team, and the data. Access is a collection of tools that allow you to efficiently process data, moving it in and out of the database, maintain the quality of the data and ensure that it remains consistently entered and valid, gain insight into the trends, areas of opportunities, and performance metrics through a series of analytical processes, construct organized and detailed reports to help guide informed decisions, and automate tasks to help prevent processing errors and speed up workflows. Simply put, a well-crafted Access database can give you way more than you put into it. To do all of that, an Access database uses 5 main components. These components are collectively called database objects, and each has a unique role to play in managing your data. The first object is a table. Tables are where the data lives. They provide a structured home organized into fields and records. The next objects are queries. Queries are literally questions that you have about the data. Queries scour through your data tables to find the answer to a question, and then return an answer as filtered or calculated list of records that look and function just like a table. Forms provide interactive framework for your database. They hold buttons for moving from task to task, text entry fields to help you enter data into your tables, and input areas to help you define the parameters for a query or report. Reports gather information from a table or query and then format them for a standardized page layout, ready to be printed, exported, or emailed to colleagues. Finally, macro objects are sets of programmatic instructions that you will create that tell the database how to function when you click on a button or interact with a form or other object. They can automate some fairly complex tasks. It is the interaction of these 5 components that makes a database function. For instance, a form might help you enter data into a table. A query will then filter those records to a specific subset, and then a report will format that subset of records for printing. To create our objects, we'll be using multiple working modes called views. These can be grouped into 2 categories. The standard view is the one you'll use when you're working with your data. Depending on the object, we'll use datasheet, form, report, or print preview views. These will display our objects when we're working with the information contained within the database. The other views are used when creating or modifying the structure of the objects. The design, layout, and SQL views all allow you to define how the database functions. Finally, it's important to understand the relational structure of an Access database. Take a look at the following problematic table of contact phone numbers. In this table, you'll notice that the first and last names are repeated over and over again every time that there is an additional contact phone number. We can structure this data differently, but that introduces a new problem. Now we have lots of blank cells where individuals don't have a contact number of each type. Further, this table won't grow very well. What if we wanted to add a fax number for one individual, or a second office number? We would have to alter the structure of the table to add an additional column to accommodate those types of changes. A relational database solves both problems. Unlike a flat file database, such as an Excel spreadsheet, Access organizes data into multiple tables that connect to each other through common fields called keys. Using the exact same data, we can organize our phone numbers like this, where we have one table that's just about people and another table that's just about phone numbers. By linking the 2 tables together with a key, in this case an employee ID, we can accommodate growth and prevent inefficiencies in our storage. We can easily add new people or additional types of contact numbers without altering the structure of the tables. We'll expand on all of these concepts throughout this course, and we'll be creating several objects in each of the 5 types, hooking them together to build a relational database that will efficiently store data, return answers to our questions, perform analysis, and generate reports.